Cities are evolving, not in theory, not in the distant future, now. Across the world, urban environments are becoming more connected, more responsive, and more intelligent. Infrastructure is no longer simply built, it is integrated. Transportation, energy, communication, security, housing, data, and public space are beginning to operate as part of a larger connected system. This is the foundation of the smart city. A city designed not only to support human activity, but to anticipate it, to respond to movement, to adjust to demand, to organize complexity in real time. The world of tomorrow is no longer a prediction, it's being assembled today. At the core of the smart city is connectivity. Systems that once operated independently are now part of a unified network. Sensors, devices, and platforms continuously collect and exchange information, creating a dynamic picture of the urban environment. Data flows across infrastructure in real time. Traffic patterns, energy consumption, environmental conditions, public movement, all of it is captured, processed, and translated into actionable insight. This constant exchange enables systems to adapt as conditions change. Signals adjust, resources shift, networks respond. Not through isolated control, but through coordinated interaction. The result is a city that is no longer static. It is aware, responsive, continuously optimizing. And the next layer, connectivity becomes intelligence. Data alone is not the objective. Interpretation is. Across smart city systems, information is continuously analyzed, filtered, and translated into decisions. Not at a single point of control, but across distributed networks operating simultaneously. Patterns emerge, trends are identified, responses are generated in real time. Traffic adjusts before congestion forms. Energy distribution shifts as demand changes. Public systems adapt to movement, density, and activity. These processes are not manual. They're embedded, automated, designed to operate continuously without interruption. The result is not just a connected city, it's a city that makes decisions quietly, constantly, at scale. As these systems expand, their impact becomes increasingly human. The smart city is not defined by its technology alone, but by how that technology integrates into everyday life. Movement becomes more fluid, access becomes more seamless. Services become more responsive to individual needs. From transportation and public space to communication and resource availability, systems are designed to operate in the background, present but not obtrusive, supporting daily activity without requiring constant attention. Interactions become simplified. Decisions become easier. The complexity of the environment is managed behind the scenes. For the individual, the experience is not one of control, but of continuity. A city that adapts without disruption, that responds without friction, that supports without being seen. What's being developed today is not limited to a single city. These systems are scalable, transferable, designed to operate across regions, environments, and infrastructures of all sizes. From emerging urban centers to established metropolitan areas, the underlying framework remains consistent. Integration, responsiveness, continuous optimization. As adoption increases, these networks begin to extend beyond individual locations. Cities become interconnected. Data moves across boundaries. Systems align across regions. What was once local becomes global. A shared layer of infrastructure begins to take shape, not defined by geography, but by connectivity, not constrained by scale, but enabled by it. This is not a single implementation. It's a model, a framework designed to expand, to adapt, to replicate. As these systems continue to develop, the structure of the city itself begins to change. Infrastructure is no longer defined solely by physical space. It's defined by interaction, by flow, by the continuous exchange of information across every layer of the environment. What emerges is not a new type of city, but a new way of understanding how cities function. Less rigid, more adaptive, designed to evolve over time. This is not a fixed endpoint, it's an ongoing process. A shift towards environments that are capable of responding, learning, and improving continuously. The world of tomorrow is not something to be built once. It's something to be maintained, refined, expanded. Smart cities, the world of tomorrow. Mobility within the smart city is continuously evolving. Transportation systems are no longer isolated networks. They are integrated into a broader framework of data, infrastructure, and real-time coordination. Movement is monitored, analyzed, and optimized across multiple layers: public transit, personal vehicles, pedestrian flow, micro-mobility solutions, all operating within a shared environment. A condition that changes and the system responds. Routes adjust, signals synchronize, resources are allocated dynamically. The objective is not simply speed, it's efficiency, continuity, a reduction in friction across the entire network. delays are minimized, congestion is anticipated, movement becomes more predictable even as demand fluctuates. At scale, this creates a transportation system that is not reactive but adaptive, designed to support constant flow across increasingly complex environments. Energy within the smart city is managed as a dynamic system. Generation, distribution, and consumption are continuously monitored and adjusted in real time. Traditional boundaries between supply and demand begin to dissolve. Infrastructure becomes more flexible, more responsive to changing conditions. Across the network, resources are allocated based on need, availability, and efficiency. Energy flows are balanced. Load is distributed. Systems adapt as usage patterns shift throughout the day. Renewable sources are integrated into the broader grid, not as isolated inputs, but as part of a coordinated framework. Storage, distribution, and utilization operate together. Environmental conditions are also factored into system performance. Temperature, air quality, resource availability all contribute to how energy is managed across the environment. The objective is not only sustainability, it's continuity. A system designed to operate reliably under varying conditions while reducing unnecessary consumption. Security within the smart city is integrated into the broader system architecture. Monitoring is continuous but distributed. Information is collected across multiple points within the environment, creating a layered understanding of activity and movement. Public spaces, transportation systems, and infrastructure networks are all part of this framework. Data is analyzed in real time. Patterns are identified. Anomalies are detected as they occur. Response mechanisms are coordinated across connected systems. Resources are deployed based on situational awareness. Communication between systems remains constant, allowing for rapid adjustment as conditions change. Safety is not treated as a separate function. It is embedded within the operation of the city itself, designed to operate quietly, consistently, without disruption. The objective is not visibility, it's presence. A system that supports stability while remaining largely unseen. Communication within the smart city operates as a continuous network. Information moves across systems without interruption. Devices, platforms, and infrastructure remain connected at all times. Data is transmitted, received, and processed across multiple layers simultaneously. From individual interactions to large-scale system coordination, connectivity remains constant. Networks support not only communication between people, but communication between systems. Signals are exchanged. Processes are synchronized. operations remain aligned across the environment. As capacity increases, so does the ability to manage complexity. More devices, more data, more interactions, all integrated into a unified framework. The result is not simply faster communication, it's consistent communication. A network designed to maintain connection under changing conditions, to support continuous operation across an increasingly interconnected environment. The smart city is not defined by its systems alone. It's experienced through its spaces, through structure, through form, through the environments people move through every day. Architecture becomes more than design. It becomes the interface, a point of interaction between people and the systems that surround them. Buildings respond, spaces adapt, environments evolve alongside the need of those within them. Materials are selected not only for strength, but for performance, for longevity, for integration. Every surface, every pathway, every structure contributes to a larger connected environment. Public spaces become dynamic, flexible, capable of supporting a wide range of use across time. Movement flows naturally. Access remains continuous. The built environment supports both activity and stillness. From large-scale infrastructure to the smallest physical detail, design is aligned with function, not imposed, but integrated. The result is not simply a collection of structures, it's a united, unified environment. An environment designed to support how people live, how systems operate, and how cities evolve over time. And as these elements come together, technology, infrastructure, communication, environment, they begin to disappear into the background. What remains is not the system, but the experience. A city that feels seamless, responsive, connected. A city that operates continuously, adapts automatically, and evolves without interruption. Not defined by any single component, but by the relationship between them. And in that relationship, a new standard begins to emerge, not just for cities, but for how we design the world around us. The question is no longer what a city is, but what it can become. Smart cities, the world of tomorrow.